Hi friends, we discuss today nitrogenous compound, the preparation of primary amines. The preparation of primary amines arises from various type of reactions. By reductions of nitro compound, alkyl cyanide, acid chloride, aldoxine, and amines. And second, the primary amines get informed by rearrangement reaction. Say for example, Hoffman degradations of amines, Smith reactions, Cartier's rearrangement, and Lawson rearrangement. And third one is the preparation of primary amines from Gabriel Pthalamide synthesis via alkyl halide, and then we prepared primary amines from Gigner reagent, and last the preparation of primary amines by hydrolysis of alkyl isocyanate. Today we only discuss the by rearrangement reaction of different types of compounds, and we get primary amines. What is primary amines? Primary amines is RNH2, where two hydrogen atoms to one nitrogen atom is called primary amines or 1 degree amines, or primary amines. The preparation of primary amines, number one, by reduction of nitro compound, reduction of alkyl cyanide, reduction of acid chloride, aldoxine, and amine. Reduction of nitro compounds, reductions of aldoxine, reduction of amine, reduction of alkyl cyanide and acid chloride. Alkyl cyanide and acid chloride. And secondly, the rearrangement reaction. Today we discuss only the rearrangement reaction of different type of compounds to get a primary amines by rearrangement reaction. Number one, Hoffman degradations, which are famous reactions. Hoffman degradations. Number two, Smith reactions. Number three, Cartier's rearrangement. Number four, Lawson rearrangement. And third one, by the reduction of by Gabriel's form, Gabriel's Amines synthesis by Gabriel Pthalamide synthesis. Number four, from Gigner reagent. And number five, by hydrolysis of alkyl isocyanate. Today we only discuss the by rearrangement reaction to prepare the primary amines. At first, we only discuss this part by rearrangement reaction. First of Hoffman degradation, second of Smith reaction, third of Cartier's rearrangement, fourth of Lawson rearrangement. Today we discuss the by rearrangement reaction. rearrangement reaction. At first, Hoffman degradation. Hoffman degradation is carried out by when acid amide on being heated with bromine and in presence of concentrated KOH we get amines. We get amines. Say for example, when acid amide, what is acid amide? RCO NH2. This is called acid amide. Acid amide. When acid amide is treated with KOH in presence of concentrated KOH, bromine in presence of concentrated KOH, we get RNH2. That is called Hoffman degradation. Say for example, R, where R is alkyl group, 1 degree amines or primary amine. Say for example, when methanamide is called methanamide is treated with bromine and in presence of concentrated KOH we get methylamine. But what is the mechanism behind it? We discuss the mechanism of this reaction and why is also called the rearrangement reaction. Why is called degradations? Here they are in this reaction in methylamine, methanamide. Here two carbon is present, two carbon are present. But when we get primary amine, methylamine, we get one carbon. There are two conversion of two carbon to one carbon. They degraded. That is called degradation reaction. But a question is why it is called rearrangement type reactions. So we discuss the mechanism of this Hoffman degradation. We can easily understood the why it is called, but why it is termed as a degradation rearrangement reaction. At first, the mechanism of this reaction is carried out. RCO NH2 concentrated KOH. Here this hydrogen is acidic in nature. Why acidic in nature? Here this hydrogen is acidic in nature because the hydrogen is with nitrogen atom which is more electronegative. Then hydrogen is weak. Then OH minus attack in H plus treated as a base. Why base? When negative charge attack on the hydrogen, that is called base, and when negative charges attack on the except hydrogen is called the nucleophile. Then we get RCO NH minus and water, RCO NH minus plus water, and there with bromine Br2. This negative charge attack the bromine as a good leaving group. Then we get RCO NH Br. RCO NH Br. Then again we treat it with concentrated OH. Then we get acidic. There is acidic, highly acidic hydrogen. Again OH minus attack on hydrogen and we get this compound RCO N minus Br. In this step is so important. Why so important? There are rearrangement occur. The rearrangement occur in this step. this step. How rearrangement occur in this step? Here nitrogen has a negative charge. They electron donate the CN bond towards and alkyl group get, then carbon get valency 5 and then alkyl group migrate to Rn and bromine as a leaving group. That is called, then we get isocyanate Rn double bond CO plus Br minus. That is, this called isocyanate. Isocyanate. This isocyanate is treated with water and then we get a primary amine. Step OA1 wait. This isocyanate is treated with water. What will be added? What is the mechanism behind it? Mechanism would be H plus. Water means H plus OH minus. OH must attack on carbon atom, and this bond to break up with and negative in nitrogen minus attack H plus. Then we get R NH C OH O. Then we get here, this one is highly unstable. Then you get pyrimidine along with carbon dioxide. Pyrimidine RNH2 along with carbon dioxide. This is all about Hoffman degradation. What is Hoffman degradation? When acetamide is treated with bromine in presence of concentrated KOH, we get 1 degree amine, that is also called pyrimidine. Say for example, we treated phthalamide with bromine in presence of concentrated KOH, we get the methylamine. Why that is called degradation reaction? Here the facts about this reaction. Facts. Here we get higher carbon compounds to higher carbon to lower carbon compound. That is called degradation. And here rearrangement occur. The rearrangement product is rearrangement product is formed is alkyl isocyanate. This is the fact. When methalamide is treated with bromine in presence of concentrated KOH, we get the methylamine. Then the mechanism, what is here? KOH act as a base and bromine act as a joint in nitrogen atom. Then we get the alkyl isocyanate. When alkyl cyanide is treated with water, the source of water is this one. First step. When alkyl isocyanate is treated with water, we get primary amine along with carbon dioxide. And second, we discuss Smith reaction, which is also a rearrangement reaction. The preparation of 1 degree amines from Gabriel Pthalamide synthesis. When these reactions is proceed on via following steps. At first, when phthalamide is treated with a ethanolic KOH to form a potassium phthalamide. At first, we must know what is phthalamide, and then we further extend the reaction. At first, we know preparation of phthalamide. Preparation of just one minute. Phthalamide. Phthalic acid. When phthalic acid is heated, phthalic acid is heated, then we get phthalic anhydride. That is phthalic acid. That is phthalic anhydride. and then Phthalamide is treated with ammonia. Treated with ammonia. We get Phthalamide. We get Phthalamide. Phthalamide. And that is called Phthalamide. What is Phthalamide? The preparation of Phthalamide is via this following way. When phthalic acid is treated, we get the phthalic anhydride. When phthalic anhydride is treated with ammonia, we get the Phthalamide. At first, Phthalamide is treated with ethanolic acid to form potassium Phthalamide. Step 1, that is the Gabriel synthesis. Gabriel Phthalamide synthesis. When Phthalamide with concentrated KOH. Concentrated KOH, we get this product is known as potassium Phthalamide. Concentrated must be in ethanol with KOH. We get potassium Phthalamide. This is known as potassium Phthalamide. Then this step 1. In second step, when potassium Phthalamide is this is the crucial step. Just treat with, then potassium Phthalamide is treated with alkyl halide to form inalkyl Phthalamide. When the potassium Phthalamide is treated with alkyl halide. This alkyl halide we get N-alkyl Phthalamide. Step 3. In step 3, when N-alkyl Phthalamide, in the last step, in the final step, N-alkyl Phthalamide reacts with potassium hydroxide to give potassium phthalate and primary amine. When N-alkyl Phthalamide is treated with KOH, then we get and primary amines and potassium phthalate. Then we get potassium phthalate and primary amine. This is the step. Then upon step 1, step 3, in a context, we can conclude that in a context we can retain as Phthalamide in first step is treated with concentrate KOH, and then in second step treated with KOH. concentrate KOH RI, and second step KOH value. Then we get potassium phthalate and amine. This is the in a context reaction. Potassium phthalate and quantity amine. In this reaction, in this step 2 reaction, this reaction is carried by via SN2 reaction. SN2 reaction. Why? This Gabriel potassium phthalate act as a strong nucleophile. This potassium phthalamide act as a strong nucleophile. Strong nucleophile. We know strong nucleophile favors SN2 reaction. We know strong nucleophile favors SN2 reaction. Then the choose of RI, there is various factors involving in this reaction. Now we discuss the preparation of primary amines for Gabriel phthalamide synthesis. What is the mechanism behind this? Now we discuss. Here we get potassium phthalate. Potassium phthalate. In second step, phthalate is treated with alkyl halide. Alkyl halide. What is the name of the mechanism behind it? Here in alkyl halide is treated as a strong nucleophile. We know strong nucleophile favors SN1 reaction, SN2 reactions. SN2 reaction. Here in potassium phthalate act as a strong nucleophile which favors SN2 reaction. Then alkyl halide must be 1 degree and 2 degree, not 3 degree. Then we get in this mechanism, SN2 attack always backside to side. We get enalkyl phthalamide. And in second step, this act, second step, enalkyl phthalamide treated with KOH. KOH means OH minus. OH minus attack the keto group, carbonyl group in the alkyl phthalamide. It is the carbonyl group. Attack we get this product. OH minus attack another carbonyl group, and then we get carrying acid. And this anion take up 2 acidic hydrogen from carrying acid. Then we get potassium phthalate and RH2. Potassium phthalate and RH2. This is the mechanism behind the Gabriel phthalamide synthesis. At first, N-alkyl phthalamide by substituted with alkyl halide, we get N-alkyl. When in potassium phthalamide is treated with alkyl halide, we get N-alkyl phthalamide. This is the follows SN2 mechanism. Why? Here potassium phthalamide is treated as a strong nucleophile which favors SN2 mechanism and we get N-alkyl phthalamide. Then N-alkyl phthalamide react with concentrate pH, we get potassium phthalate and RNH2 via following mechanistic ways. Now we discuss the factor involving in this Gabriel phthalamide synthesis. Facts. Fact 1. What is the fact 1? In this Gabriel phthalamide synthesis, aryl halide is unable to produce aromatic amine. It is due to fact that aromatic halide inert towards nucleic substitution. Fact 1. In this Gabriel phthalamide synthesis, Gabriel phthalamide synthesis. In this Gabriel phthalamide synthesis, aryl halide is unable to produce aromatic amines due to fact that the aryl halide inert towards both SN1 and SN2 mechanism. Then energy, which means that is potassium phthalate is treated. Say for example, chlorobenzene. The reaction does not proceed. Why? This chlorobenzene carbon chlorine bond. This carbon is sp2 carbon. In sp2 carbon, SN2 reaction is not possible. And in this reaction, carbon chlorine single bond gets double bond via resonance. That is SN1 also is not possible in this reaction. That is why in this Gabriel phthalamide synthesis, the aromatic amines is not produced from aryl halide. This is the factor number 1. And factor number 2, facts 1, and with the synthesis of the alanine. Fact 2, the synthesis of alanine by Gabriel phthalamide synthesis. Application of Gabriel phthalamide synthesis. Applications of Gabriel phthalamide synthesis. At first, synthesis of alanine. What is alanine? Alanine is a chiral amino acid. Chiral amino acid, which is the monomer of protein. Synthesis of alanine. Alanine is called amino acid. This is called alanine. How do they defect? This is alanine. When potassium phthalate is treated with 2-chloro-propanoic acid, 2-chloro-propanoic acid, propanoic acid, we get alanine, which means that is potassium thalate, which is CH3CHCl. This 2-chloro-propanoic acid. Then we get, in presence of pH, we get alanine, NH2 pH CH3 COH and this product. And fat food, when besides in presence of pressure and heat, inalkyl phthalamide on being hydrolysis by dilute to form 1 amine. Besides in presence of pressure and heat, presence of pressure and heat, inalkyl phthalamide on being hydrolyzed we get hydrolyzed by this cell to form 1 amine, which is mean NLP phthalamide is heated in case of damaged breakfast. We get phthalic acid and primary amine. This is the fact 2. And fact 3. When NLP phthalamide is treated with hydrazine to also get 1 amine. When NLP phthalamide is treated with hydrazine, we also get 1 amine. Yeah, thank you. The Gabriel thalamus is very short. We may conclude that when phthalamide is treated with concentrate pH, we get potassium phthalamide. In step 2, when the Phthalamide is treated with alkaline, we get primary amine and potassium salt and phthalic acid. The reaction, the mechanism is we already have discussed, and then the facts about this reaction. Number one fact, when in this reaction, Gabriel Phthalamide synthesis, arachidonate is unable to produce aromatic acid. It is due to fact that the aromatic alike inert towards both SN1 and SN2 reactions. And fact number 2, besides in presence of pressure and heat, N-alkyl phthalamide also produce 1 degree amine on being hydrolyzed by dilute HCl. And fact 3, N-alkyl phthalamide react with hydrazine to also form 1 degree amines. Here in Gabriel Phthalamide synthesis, we synthesize the alanine, which is a amino acid which is optically active. And this is all about we have discussed today in this lecture. Thank you.